In this video, we are going to talk about the uniform distribution. Now, we had just talked about continuous functions, and a continuous function means that your probability can start at 0 and end wherever the area map sends us to, and I think it would be good to kind of refresh ourselves on the notation for just normal x's in general. Now, the x here is going to belong, and we've used letters like b to represent the binomial distribution, but we're going to use a big letter U to represent the uniform distribution, and the uniform distribution is going to go from A to B, and A is going to be your minimum value, and your B is going to be your maximum value. So x belongs to the uniform distribution of numbers from A to B and all the numbers in between, all the decimals, all the fractions, every single number between these two. So suppose you have smiling times for infants in seconds, and let's allow a uniform distribution between 0 and 23 seconds inclusive. Inclusive means that they can also equal the numbers 0 and 23. Which means that you will see sometimes the word exclusive, which means you can't include them. So inclusive would be 0 to 23, and this is including 0 and 23, but the word exclusive would mean 0, this x would go between 0 and 23, but not including 0 or 23. So the notation for this uniform distribution is x belonging to the uniform distribution between 0 and 23. Again, our minimum and maximum. So our probability density function. Our probability density function for this problem is going to be the function of x, or y equals 1/23 when x is between and including 0 to 23. Now, if you were curious how you create your probability density function, you create it from the denominator of the maximum, and it is going to be from 0 to this maximum here. The theoretical mean formula, and this is going to be given to you here, and I would suggest you have this out when you do your homework. The theoretical mean formula is the mu is equal to a plus b divided by 2. So if you take your minimum and maximum and add them up, divide by 2, you can find your average. So we know our minimum is, this is our A and this is our B. So A, the minimum, is 0 plus 23. 0 plus 23 divided by 2. So 23 divided by 2 is equal to 11.5. And that's the average of the mean smiling time of these infants, acknowledging with a smile between 0 and 23 seconds. Now let's do the theoretical standard deviation formula. Luckily, this formula isn't as big as some of our other standard deviation formulas, so our lowercase sigma is going to be equal to the square root of b minus a, that's our maximum minus minimum squared, divided by 12. And 12 has been found through some more advanced math that you just don't need to learn for this standard class. So let's do this. Now the first thing I would do is work from the inside out of this equation. So you'll notice we have our maximum 23 minus 0, quantity squared, divided by 12. So doing order of operations, we process the parentheses first. And processing the parentheses would be 23. And we're going to square that. Divided by 12, and then take the square root. 23 squared is 529. Divided by 12, and take the square root. Now, if we type into the calculator 529 divided by 12, and then take our square root, we get first, the 529 divided by 12 is 44.083 repeating. Then we take the square root of that, and the square root of that will be 6.64, or if you want to round that to about 6.64 seconds. So this, again, showing my steps here, this is the square root of 44.0 8, 3 repeating, and then you take the decimal of that. This is going to be, after the square root, 6.64 seconds. So what this means is that you have a standard deviation that's give or take 6.5 seconds on average. So again, rounding that to 6.5 to convey this a little easier. So the average is 11.5 plus 6.5 would be 18 seconds, and minus 6.5 would be 5 seconds. So to a normal person who doesn't necessarily understand what standard deviation means, just explain it to them as the give or take off of the average. Now let's find some probabilities. What is the probability that an infant smiles between 2 and 18 seconds? Okay, so we're going to draw our area map. So we're going to draw a rectangle, and that rectangle is going to go between 0 and 23 seconds. Our height of the rectangle is going to be 1 over the maximum. And it's 1 over the maximum because we have 23 sections. And 23 23rds is going to give us 1. Now we want the probability between 2 and 18 seconds. So we want to know, what is the chance of us landing inside of this zone right here, between the 2 and the 18. To find that out, let's do a little work. The probability between x being between the 2 and the 18 is going to be equal to the base times the height of this object. So the base of this object is between 2 and 18. So we're going to figure out that distance by going maximum minus minimum inside the yellow zone. And some of you could have just known that was 16 units wide, times the height, which is 1/23rd, which gives me 16 23rds, because 16 over 1 times 1 over 23rd is top times top, bottom times bottom, or 16 23rds. And if I do this, I get an answer of 0.70. And this is rounded correctly. The 16 23rds, if you did it on the calculator, would be 0.6956, which is rounded to 0.70, which is you have a 70% chance of the infant smiling between 2 seconds and 18 seconds. Now we're going to find the 90th percentile of the smiling time. So we know this percent. This is 0.90, so we know this. So we know that the base times the height, which gave us our probability here, can now give us this probability of finding the probability of 90%. So you see now that we have 0.90 is equal to base times height. Look in the previous problem. The number to the left is 70%. 70% is base times height. So now that we know this, we know that this value is 90%. So, the base in this case, we actually don't know the base. If we knew the width, we would then figure out that that width would give us the 90%. So what we have is 0.90 is equal to x. But we do know the height, and the height in this case is 1/23rd. Now we need to solve for x. Now one of the ways we could do this problem is we could divide both sides by 1/23rd. So 0.90 divided by 1/23rd will give us our answer for x if we have technology. Another way we could do it is multiply by the reciprocal, something you learned in your basic algebra classes, and we could multiply by 23 over 1. Because 1 times 23 and 23 over 1 is 23 over 23, which is just 1, and 1 times x is x. 23 times 90 is going to give us an answer of, 29 times 0.90 is going to give us an answer of 20.7. So our x is going to be 20.7 units long. So if I was to create a new picture up above, our 90th percentile would be all the way to the end of this green bar, and this green bar would end at 20.7 seconds. So our 90th percentile would be 20.7 seconds. So anything higher than that would be higher than the 90th percentile, so 90 to the 100th percentile. And anything lower than 20.7 would be obviously below the 90th percentile. So for this end of the video, we are going to take a look at conditional probability in the uniform distribution. So we know that in this study, infants are going to smile within 0 to 23 seconds. But what if we want to take a look at infants smiling after 12 seconds out of the group that will smile a little later? So of those who smile after 8 seconds, what is the chance of having a baby that smiles around 12 seconds or later? So this conditional probability is choosing x greater than 12 from the group of x greater than 8. So let's kind of remind ourselves what conditional probability means. We want the group of x greater than 12 from the group that was greater than 8 anyway. So I'm going to teach you two different ways to do this. I will tell you straight up that it is probably easier to do the area map method than actually the mathematical method, which I will show you at the bottom of this worksheet here. So the area map method deals with the original area map, and that was from 0 to 23 seconds. And we make our rectangle, and according to this model, we would have the height be the maximum. And what we're looking for is we're looking for those babies who smiled after 12 seconds from the group that smiled after 8 seconds. So what I'm going to do is I'm going to kind of highlight what we're looking for. We're looking for this highlighted yellow area. So we want to find the area that of this yellow bar, what are the chances that we would land in the green bar? So from the yellow bar, what are the chances we would land in the green bar? So here's how we could draw the conditional area map. So instead of drawing it from 0 to 23, we only need the yellow bar from 8 to 23. So now my height, which was set at 1/23, is now a little taller. In fact, it's 1 over, and this is where you might think that we just put the 23 there, but that's not true. The reason why we use the 23 up here is because we had 23 sections making up this entire area. But now we don't have 23 sections. In fact, we have 23 sections minus the 8 that we're not using to the left of the number 8. So 23 minus 8 is 15. So our denominator is not 23, it's 15. Now, that might cause a little bit of confusion because you've been saying, well, gee whiz, it looks like this denominator has always been set up as 1 over the maximum. And that was a really good way to explain it since the bar went from 0 to 23. But in fact, we can now say that the denominator is our max minus min. And we've been seeing that all through this little worksheet here as the height of b, which is our maximum, minus a. So 1 over b minus a, sorry, that looks like a 13 there, b minus a gives us this 1 over 23. So 23 minus 0 is 1 over 23, and 23 minus 8 is 15. Now what we want to do is we want to find what is the probability of us landing in this green section. Well, since we've been doing this all throughout the worksheet, our answers of the probability is going to be base times height. So the probability that x is greater than 12, having chosen the group of x is greater than 8, is going to be base times height. Now the base of this entire section here, because we have to take a look at the green section here, we have to take a look at the green 12 and the green 23. The base is going to be our 23 minus 12. So this is the green section out of the whole height of this object, which is 1/15. So 23 minus 12 is going to be 11 times 1/15, which is 11/15. Now there's a few of you having seen enough of these right now to realize that, oh wait, so this green section has 11 chunks in it, and this entire rectangle has 15 pieces or chunks in it, so that would be 11/15. And that's another way you could look at it, which gives you 0.73 repeating, or 73.3%. So this is my favorite method to use for conditional probability. Start off with, and again, just to kind of go over what we did, start off with the entire piece, and then after you start with the entire piece, you split it up into the group that you want, which was yellow, and figure out what you need, which is green, and then do the entire problem again, except in this case, your yellow is going to be your denominator, 15, and your green is going to be your numerator, 11. And you can also use the base times height model to figure that out as well. Lots of different ways to do this, and the most, I'd say mathematical method, but maybe not necessarily the easiest method, is this way. And if you really like the previous method, copy these in your notes and then just use the previous method. But the mathematical method states that the conditional probability is defined as the probability of A and B happening divided by the probability of B happening. So let's look at the probability of A and B. Now remember, in this case, A was equal to x greater than 12, and B was equal to x greater than 8. So our numerator of this probability method is going to be A and B. So x is greater than 12, and x is greater than 8. So logic, then, brings us to our full area map. We're not going to be splitting this up at all. We're going to still use it as our 1/23. And what the numerator is asking, it's like, okay, I want x bigger than 12, and at the same time I want x bigger than 8. Well, what numbers are bigger than 12 and bigger than 8 at the same time? And those would be the numbers that are bigger than 12. That's the logic of the mathematics. If you have to be bigger than 12 and bigger than 8, then you're definitely going to be bigger than 12. So this gives me my light blue area. Now we can figure out the area of this by doing our base times height. Okay, so to figure out our probability of the numerator of A and B happening at the same time, this would be the probability of our, hold on a second here. So this is A and B. And so therefore we're going to do the base times height here. And I'm going to kind of skip over that little 12 there and change this to this color here. I'm going to change it to red and do my work over here on the side. The base of this rectangle is going to be 23 minus 12. And the height is going to be 1/23. And 23 minus 13, 12 in this case. 23 minus 12, come on, give me the red pen there. Sorry, I'm a little trouble with my stylus. 23 minus 12 is going to be 11 times 1/23. So that means my numerator here is 11/23. All right, I'll get rid of this here. Now my B is going to be x greater than 8. So I'm going to make my picture here, going from 0 to 23 with my height of 1/23. And this time I just want, for this one down here, I want to go 8. So this is going to be my purple region, because my denominator here is going to be the probability of b. And the probability of b is just x greater than 8. So what that is going to do, it's going to give me this probability of b is equal to base times height. So the base in this case is going to be 23 minus 8 times 1/23rd. And 23 times 8, or sorry, 23 minus 8 is going to be my answer of 15 times 1/23rd. And 15 times 1/23rd is 15 23rds. So I got a fraction divided by a fraction. Now, if you have a calculator, you can type that in pretty easily. 11 23rds divided by 15 23rds, and you'll get an answer. Now, if you took some college algebra, what you can do is, instead of writing it this way, you can write it this way. You can take your first fraction, which is 11 23rds, skip that fraction, flip the fraction over here, this 15 23rds, and write it as 23rd 15ths, and then multiply. Because dividing fractions, please don't cry. Skip the first one, flip the second one, and multiply. These simplify to 1. I know a lot of people say cross cancel, but they're technically dividing to make 1, which makes 11 15ths. Which also should sound kind of familiar, because if we work a little bit higher, we can see that 11 15ths is the same answer here as it was here. So I think you should choose the method for conditional probability that best you can understand. But this brings us to the end of our little worksheet. That brings us the uniform distribution, or continuous distribution functions, and we can now see how they are definitely a lot different than the discrete functions that we've been working with in the previous 2 videos. Thank you for watching.